and welcome to PIKE's mini webinar. For today's topic, we're going to talk about Jackfish electrochemistry cells. We'll introduce the new J2 and also do a comparison between the J1 model and the J2 model from an applications viewpoint. Before we get started, let me introduce you to the presenter, Ian Anvag. Ian is the CEO of Jackfish, and he is also working on a master's degree at the University of Saskatchewan in Ian Burgess's group. The relationship between PIKE and Jackfish is a few years old now, and during this time, end users and I have truly benefited from Ian's expertise and advice on everything electrochemistry. So now let me go ahead and turn that over to Ian.
All right. Thank you very much, Jenny, for that kind introduction. So yes, I will be speaking today about how to select a Jackfish spectroelectrochemical cell for your research. And so just a brief word about Jackfish ourselves. Jackfish is a startup company that spun out of the University of Saskatchewan in 2018. We're not that old, but our initial product, the J1 cell, has been a long time in the making. We started designing cells about 10 years ago, and we ended up with something we were happy with in about 2018. And we've kept tinkering, and we are just excited to release today a new product, the J2 cell, for organic solvents. And so I'm going to walk through today a little bit about this cell and how you might choose which cell is best for your research application. So first, a little bit about infrared spectroelectrochemistry. Big word, but it is a very cool analytical technique which combines electrochemical control with the structural information that you can get from infrared spectroscopy. The preferred method to do these types of experiments is often to deposit a metal film on top of an internal reflection crystal, such as a silicon hemisphere, which can act as the working electrode. And so normally the penetration depth of a regular ATR internal reflection crystal is on the order of a couple microns. However, once you add this thin metal film on top of the crystal, you can find that to on the order of nanometers. So what you really have here is a surface sensitive technique which allows you to probe the electrically charged surface and whatever species may be adsorbed to your electrode. So to get started with this technique, what you will need is an infrared spectrometer and a potentiostat. PIKE's Vmax3 optics box will redirect the infrared beam from your spectrometer and direct it onto the sample, providing you with angle of incidence control. And then on top of that, you will mount an electrochemical cell, and that's the topic that I'm going to discuss today. So Jackfish has two main products, the J1 and the J2. And so both of our cells are designed to be used in attenuated total reflectance mode. So this will have the major advantage of avoiding light losses due to absorption by the solvent. So the cells are designed to be used on top of an ATR crystal, which is installed into a Vmax3. So they're all compatible with the Vmax3. And both of our cells feature inert materials, which can be easily cleaned using standard electrochemistry procedures, such as acid baths. They also feature 3 electrodes. So you have your counter electrode and your reference electrode and your working electrode. And the novel contribution that we recently made was to improve the electrical contact made onto your working electrode with a spring-loaded pin design, which delicately makes contact with the film so that you do not damage your metal film, which can often be very delicate and prone to damage. So let's jump right in and talk about some of the differences between these two products. When we designed the J1 cell, we really had aqueous chemistry in mind. So it uses the most inert materials for the cleanest electrochemistry. So all of the joints in the J1 cell are ground glass joints, which can easily be cleaned and seal the cell quite well when they are wetted. However, the joints will not seal if you are using an organic solvent unless you are going to also apply grease. And grease is obviously very undesirable for electrochemistry, where cleanliness is very important. So there are 3 ports on top of the cell, which will allow you to introduce purge gas into the headspace above the electrolyte, as well as a long bubbler, which will allow you to purge the electrolyte itself and displace oxygen that is dissolved in it. On the other hand, the J2 is designed primarily for organic solvents. So this cell uses O-rings to achieve a much more airtight seal as compared to the J1. The cell can be purged through the septum stopper using a needle. So you can use standard cannula transfer techniques or other Schlenk techniques for air-sensitive chemistry using this cell. One other advantage is that the J2 only requires about half the volume of the J1. So it might be more suitable if you're working with an expensive electrolyte, such as an ionic liquid or something like that. The J2 cell might be the choice for you. So generally, in broad terms, we would recommend the J1 cell for your standard electrochemistry in an aqueous environment, and the J2 cell if you're using volatile solvents or working with air-sensitive chemistry. But there are a number of other differences between the two cells that also might impact your decision. So I'm going to go into those in the next couple slides here. So one of the main considerations is your reference electrode. The J1 has a separate reference arm that is isolated from the main cell body by this wetted ground glass joint of the stopcock. And so this is essentially a salt bridge or another junction, a second junction, which will prevent the migration of chloride ions from the reference electrode into the main body of the cell. And so to use this reference arm, you can either supply your own reference electrode that you already have in your lab, or you can purchase one from us. And the reference electrode that we offer for the J1 cell is designed to be disassembled so that the silver wire can be re-oxidized and cleaned as it's needed to be regenerated so you can continue to use it. It's got a thick gauge wire that can be cleaned. On the other hand, the J2 cell comes with a completely sealed reference electrode as part of the kit. It's already included. The reference electrode is inserted directly into the cell body. So this does mean that you can have a little bit of contamination into the cell from the reference electrode filling solution over time. It can also have an added benefit for high frequency electrochemical measurements. So by eliminating this extra junction in the J2 compared to the J1, we are also eliminating the electrical double layer that is associated with that junction. And so that will act as a capacitor. And at high AC frequencies, this junction will provide an alternate path to ground through the reference electrode. And so here I'm showing a Bode plot, which shows the frequency response of each cell, which is filled with 250 millimolar of sodium fluoride. And you can see that for frequencies above about 1 kilohertz, that there's this kind of curl upward in the phase angle of the impedance for the J1 cell. And so this really is indicating that you are measuring the impedance of the reference electrode and you're not actually measuring the electrical system that you intended to study. So for high AC frequency measurements, you might want to consider the J2 cell. Another consideration is the counter electrode. And so for both of our cells, the J1 and the J2, this is an optional add-on. It doesn't come included. The J1 comes with extra short bubblers. So if you have some metal wire, you can make your own counter electrode and mount it in the short bubbler, or you can also purchase a pre-assembled platinum or gold wire already assembled in a short bubbler, ready to go directly from us. The main consideration with the J2 cell is getting a well-sealed feed-through for the wire. So Jackfish sells a platinum counter electrode, which is sealed into the glass tube without using any adhesive. However, the compression style port that exists on the J2 will accommodate any commercial third-party reference electrode as long as the body of the electrode is between 4 and 7 millimeters in diameter. So if your application requires something other than platinum, maybe you need graphite or a glassy carbon electrode, those are available from a number of third-party suppliers. So hopefully that gives a good overview of the glass cell options that we offer. And so the next consideration when selecting a cell is choosing an internal reflection element. So we offer 2 different options, face-angled crystals and micro-machined silicon wafers. Both of these crystal types are single bounce elements. So the face-angled crystals, they're very robust and they can be reused many, many times by polishing them. the cell base has a larger bore, and this improves mixing at the bottom of the cell. And it also has a larger exposed electrode area. So you have a larger working electrode compared to the wafer cell. There are several different crystal material options depending on your needs for the spectral window of the system that you're investigating. For the vast majority of users, we would really recommend using a silicon phase angle crystal with an anti-reflection coating. And so silicon, we generally recommend because it has the best metal wetting properties out of any of the available crystals. So if you're going to do the standard technique where you deposit a thin layer of film, metal film on top of the ATR crystal, silicon is probably the best bet for that. And we recommend the AR coating. It improves performance quite a lot. However, it does block all light intensity below about 1125 wave numbers. So if you need spectral information outside of that at low wave numbers, you might want to consider something else. And one of those other options that you might consider is the micromachined wafer. They're only about 0.5 millimeter thick, so scattering from silicon phonon modes is reduced as much as possible just because you have a very, very short path length through the crystal. And so this makes the wafers very useful over a large spectral range, especially in that fingerprint region where a lot of interesting structural information can be obtained. The wafers are cheaper than the phase angle crystals. However, they are more prone to breaking just because they're very, very thin. And so the last decision to make once you've selected a ATR crystal and which type of glassware you like is the type of cell base that you need. So we offer 2 different materials depending on what are the requirements in terms of cleanliness for your application. We have PIKE and we have Teflon. Generally, our recommendation is for PIKE since it has a bit more it is a bit more mechanically robust material. It's more rigid and it's less likely to be damaged through normal use. However, Teflon, once you are installing the contact screws into the cell base, it's very thin and soft deformable material. And so it's easy to cross-thread those contact screws when you're installing them into the cell base. So you have to take some extra care, but that is also an option if you need that extra little bit of chemical resistance. Both Teflon and PIKE can be cleaned in room temperature piranha solution or acid solutions for standard cleaning. However, you do need to make sure that your acid has cooled down to room temperature since the heat can cause the plastic to deform and then you won't be able to seal your cell properly. So hopefully that gives you a fairly good overview of the 2 main cell types that we offer and how to choose one that is best for your application. If you're looking for more information, you can visit piketech.org, piketech.com. And we recorded a webinar last summer that goes a little bit more into the technical details of infrared spectroelectrochemistry and can provide a little bit more background information on the technique. And of course, we'd be happy to hear from you as well. So you can contact us at our email, info@jackfishsec.com. And we'd be happy to hear about the science that you're doing and if our cell is going to work for you. And we'd be happy to discuss that with you. So thanks for your attention. Have a great day.
Thank you so much, Ian, for the very informative presentation. In addition to the webinar found on our website, you can also see some selected publications from the Jackfish team on the Jackfish product data sheet, also on our website. So thanks everyone for watching.